This is the Math 2 lesson summary video for the lesson entitled, It's All in Your Head. In Lesson 7, It's All in Your Head, the purpose of this lesson is to continue the idea of formal proof, which we started in Lesson 6, where we reason from a diagram and identify a sequence of statements that always start with given assumptions and lead to a valid conclusion. Unlike the previous lesson, which focused on paragraph or two-column proof, we start focusing on what we call flow diagram as a way to organize our thinking. There are 4 vocabulary words that we are introduced to in this lesson. The altitude, it is a line segment drawn from the vertex of a triangle that is perpendicular to the opposite side, also known as the height of the triangle. The median is a line segment drawn from a vertex of a triangle to the midpoint of the opposite side. And an angle bisector, which is a line segment or ray drawn from a vertex of a triangle that cuts the angle in half. And the last vocabulary term, perpendicular bisector of a side, is a line drawn perpendicular to a side of a triangle through its midpoint. So if we go back to Lesson 7, those definitions are in your MVP booklet, and there are diagrams that support those definitions to the right, which we discussed today in class. So we were told that Travis used a compass and straight edge, and he constructed an equilateral triangle, which we see in this diagram here. He then folded his diagram across the 2 points of intersection to construct a line segment. So there are 4 students, Travis, Tehani, Carlos, and Clarita, and they're trying to decide what to name the line segment from point C to point D. We are told that Travis thinks that he can call this line segment CD a median. Tehani thinks that she can call this an angle bisector, and Clarita thinks she can call this an altitude. And Carlos thinks he can call it a perpendicular bisector of the opposite sides. So all 4 friends are trying to convince each other that they are right. So we were asked in number 1 to support Travis's claim that it's an equilateral triangle, what we would need to show. Well, we do know, based on the fact that triangle ACB is equilateral, that line segment AC will be congruent to line segment CB, which will be congruent to line segment AD. And if Travis is to state that line segment CD is a median means that it will split the opposite side into 2 congruent parts. So if CD is a median, then Travis will have to show that line segment AD is congruent to line segment BD. Okay. In number 2, in order to support the fact that Tehani thinks that line segment CD is an angle bisector, by definition of angle bisector from the previous page, we know that it means that it will split the angle into 2 congruent parts. So Tehani will have to show that angle ACD is congruent to angle BCD. Angle ACD is congruent to angle BCD. Okay, and number 3, we are told that Clarita, again, wants to prove or show that line segment CD is an altitude of the triangle. If we go back to our definition of an altitude, it is a line segment drawn from a vertex that's perpendicular to the opposite side. So what Clarita would have to show is she would have to show that line segment, or that CD, would be perpendicular to AB. And the last one for Carlos, if he wants to show that CD is a perpendicular bisector of a side, by definition of a perpendicular bisector, it is perpendicular to a side of a triangle through its midpoint. So we would not only need to show that CD is perpendicular to AB, but we'd also need to show that line segment AD would be congruent to line segment BD. So now we're going to organize this thinking into what we call a flow diagram. And the first one we're going to start off with is Travis. So if you recall, Travis wants to prove that line segment CD is a median of triangle ACB. So what we have here are some statements, and we were given that triangle ABC is equilateral. So I've marked that in the diagram in the upper right hand corner. So that is important that we use that information in Travis's proof. The next thing we circled is that line segment CE is a line of reflection. And that is important because we need to know that line segment CE is a line of reflection in order to then conclude that D is a midpoint. And if D is a midpoint, then we can conclude at that point that line segment AD would be congruent to line segment DB, which is why those are circled for Travis's proof. Based on our knowledge from our previous lessons in this unit, we do know that line segment CD will be congruent to itself. We can say basically because of the fact that the triangle on the right, triangle CBD, would coincide with the triangle on the left, and that would be using our transformations. Or we could say that line segment CD is congruent to itself based on the reflexive property. So we have actually just proven that CD, line segment CD, is a median, so we've circled that as part of Travis's proof at the bottom. On the next page, in number 8, we were actually asked to use the arrows and braces in the flow diagram and use one of the reasons on number 8. So if we go to the next page on number 8, you see all of these reasons that were here. So what we did is we took these reasons to support each of our statements in the on the previous page. So if we go back here, the first piece was that triangle ABC is equilateral, and so we said that that would be number 4. If it's equilateral, then we know that AB is congruent to BC, which is congruent to AC, and I'll just write that over here. CE is a line of reflection, and that's going down to the fact that D is the midpoint. So we said that that would be, by definition, number 1, definition of reflection. If D is the midpoint then of AB, we can conclude that AD is congruent to DB, and that would be number 6, definition of midpoint. And we have now just proven that CD, line segment CD, is a median because we've already said that line segment AD is congruent to line segment DB above. So continuing on number 8, I'm going to stick with Travis's proof. We're going to go from the flow, and we're now going to organize the flow proof into what we call a 2-column proof from lesson 6. So if you look below here, we have put all of our statements on the left, and I'm just going to go about numbering each of my statements with its corresponding reason, and all of the reasons on the right. So now they're going to put our information into 2-column proof form. So all we're going to do is take the information from our flow diagram on the previous page and organize it differently into 2-column proof. So the first, which we always start off with in a proof, is always your given. We were given that triangle ABC was equilateral, so we can mark our diagram as such, and then the reason we can state that is that it was given. The next thing that we used in Travis's proof is that line CE is a line of reflection, and the reason we can say it's a line of reflection is because equilateral triangles can be folded onto themselves about a line of reflection. If line CE is a line of reflection, we know then that point D is a midpoint of line segment AB, so that's our next statement, and our reason is definition of reflection. So if point D is a midpoint of a line segment, then we can definitely conclude that line segment CD is a median, and the reason is by definition of a median. So we're now going to move to Tehani and her claim in that the line of reflection is an angle bisector of the equilateral triangle, so we are going to need to show the angle ACD is congruent to angle BCD. So what we did in class is we circled the given information that we needed in order to show that angle ACD would be congruent to angle BCD and to support Tehani's claim. And next to each of these statements, we did provide the reason that's given on page 8 in your MVP booklet. So at the bottom then, we circled that CD is an angle bisector, and I'm going to flip to how we wrote this in 2-column proof. So to start off a proof, we always start with our given information. So we were given that triangle ABC is equilateral. So we know that means that all 3 sides will be congruent in that triangle. The reason was given. The second statement was that line CE is a line of reflection, and we know that based on the reason that equilateral triangles can be folded onto themselves about a line of reflection. So if line CE is a line of reflection, that we know that CD will be perpendicular to line segment AB by definition of reflection. If two lines are perpendicular, then we can conclude that they are right angles, so we can say the angle CDA and angle CDB will be right angles by definition of perpendicular. We can then conclude that AD will be congruent to BD by definition of reflection. If they reflect, then they will coincide, which we've talked about in previous lessons, so we can mark them congruent. We also know that line segment CD will be congruent to itself by the reflexive property of congruence. Therefore, triangle ACD, and I'm going to highlight that triangle on the left, triangle ACD, if you notice the tick marks, and the angle in blue, will be congruent to triangle BCD, which is the triangle I'm highlighting in green. We can say that they would be congruent by side angle side congruence criteria, which we talked about in the previous lessons. Therefore, if two triangles are congruent, we know that their corresponding parts are congruent, so we can then say that angle ACD will indeed be congruent to triangle BCD by corresponding parts of congruent triangles are congruent. Therefore, CD is an angle bisector, and we know that because the definition of angle bisector, and we've just proven that those two angles would be congruent. Therefore, we have proven Tehani's claim. In class, we did also discuss Clarita's claim as well as Carlos's claim, so you'll want to take a look at that. And if you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.